Welcome, everyone. Today, I am excited to introduce Velox, a project dedicated to bringing the power of the Tauri architecture to the Swift ecosystem. Velox allows you to build lightweight, native desktop applications by leveraging the versatility of HTML and CSS alongside the performance and safety of Swift. As a Swift-first port of the Tauri architecture, Velox offers a seamless development experience for those who want to create modern, efficient applications using the languages they know best. Let's explore how Velox is bridging the gap between web technologies and native performance. When we examine the current landscape of application development, we often encounter what we call the Rust barrier. While Rust is undeniably powerful and offers exceptional security, its inherent complexity can frequently become a bottleneck that hinders our ability to ship products efficiently. This sentiment is echoed by the creator's own observation: "I am too old to develop an appreciation for poetry," or Rust. This represents the core problem, a high barrier to entry that can stall momentum for even the most capable teams. To address this challenge, we introduce Velox. Velox provides a solution by porting the robust Tauri architecture directly to Swift. Our goal is simple: to enable developers to build modern web frontends supported by native Swift backends. By leveraging Swift's elegance and accessibility, we aim to replace the friction of complex systems with a development experience that is, quite simply, pure joy. This high-level architecture diagram outlines the three primary layers that comprise Velox. At the top, the front end utilizes a standard web view powered by HTML, JavaScript, and CSS, serving as the user interface layer. In the middle, the bridge layer contains the Velox runtime written in Swift. This acts as the essential glue for handling inter-process communication and state management. Velox creates a Swift surface area that mirrors Tauri concepts, bridging into a lightweight Rust static library. Finally, at the base is the foundation layer, which utilizes a Rust foreign function interface. This hidden implementation detail handles low-level cross-platform windowing via Rye and Tau, allowing developers to build robust applications while staying firmly in Swift. Now, let's take a look at the toolchain. The Velox CLI is designed to be lightweight and efficient, built directly from the Swift package to ensure seamless integration with the existing ecosystem. Once installed, initializing a project is a single command. As you can see in the terminal example, running Velox init scaffolds a standard project structure, automatically generating your package manifest, source directories, assets folder, and configuration files. The workflow is optimized for developer productivity. It includes specific commands for different stages of the lifecycle. Velox Dev enables a hot reload development environment for rapid iteration, while Velox Build handles the final production bundling. This streamlined approach allows you to move from setup to development and deployment with minimal friction. Declarative configuration provides a centralized and predictable framework for managing application settings. By utilizing a structured JSON format, we establish central control over core attributes, such as the product name, application identifier, and fundamental build specifications. This ensures a single source of truth for the application's identity and window defaults. To accommodate diverse deployment targets, the system supports platform overrides. This allows developers to maintain platform-specific files, for example, a dedicated configuration for macOS, which are then applied via JSON merge patch. This approach minimizes redundancy while allowing for granular platform tuning. Lastly, the system facilitates environment injection. It establishes a clear hierarchy for variable flow, pulling from system environments, the primary configuration file, and local .env files. This multi-layered injection ensures that configuration remains flexible, secure, and easy to manage across all development stages. There are two primary modes of development to choose from, depending on your project's requirements. The first is local asset serving. This is ideal for static HTML and CSS projects or simple prototypes. The mechanism is straightforward, serving files directly from the assets folder. This approach provides a zero configuration experience with no Node.js requirement and an instant restart whenever you change an HTML file. The second mode is the dev server proxy, which is best suited for modern stacks like Vite, React, and Vue. In this configuration, the Velox dev command proxies requests to your local host, typically on port 5173. This mode is highly advantageous for complex projects because it supports hot module replacement, TypeScript, and comprehensive development toolchains. When determining our asset strategy, we have two distinct approaches to consider: self-contained and bundled assets. Concept A, the self-contained approach, involves embedding HTML directly within Swift code strings. This method is ideal for single binary deployments and simple tools, as it minimizes external dependencies. Alternatively, Concept B focuses on bundled assets, where HTML, CSS, and JavaScript are maintained in a separate directory. This approach facilitates a clear separation of concerns and supports a familiar web development workflow, making it better suited for more complex applications and collaborative environments. The bridge serves as the core architecture for inter-process communication, or IPC, within our system. The process begins in the JavaScript frontend, where a developer initiates an action using the window.velox.invoke method. This call passes a command and its associated arguments across a custom app protocol. Once the request reaches the Velox runtime, it undergoes a normalization process where Rust-based events are translated into typed Swift objects. These objects are then passed to the Swift backend, which executes the required closure and prepares the data to be returned as JSON. Finally, the result is sent back to the front end as an asynchronous response. This bridge effectively handles the complex translation between the web view's JavaScript context and the native Swift environment, ensuring all communication is both secure and non-blocking. The Velox command macro is central to the framework's efficiency, providing a streamlined way to define commands. By utilizing Swift macros, we achieve native ergonomics that eliminate repetitive boilerplate code. This approach ensures robust type safety, as arguments are automatically decoded from JSON into the appropriate Swift types. Additionally, it handles automatic registration, which removes the need for manual switch statements or complex routing logic. This allows us to focus on writing clean, functional code while the system manages the underlying infrastructure. Advanced communication within this architecture is divided into two primary patterns: request-response and events. Starting with the top diagram, we see the request flow initiated by a front-end invoke. This triggers an asynchronous process on the backend, which can seamlessly access the application state via the command context. Once the backend completes its logic, it returns a response that resolves the initial promise in the front-end. Moving to the bottom section, we have events, which facilitate backend to front-end streaming. In this model, the backend serves as a continuous streaming source, pushing data packets or notifications to the front-end. The front-end operates as an event listener, allowing the application to react dynamically to backend updates without the need for a direct request. This dual model approach provides the flexibility needed for both immediate command execution and real-time state synchronization. The application lifecycle in Velox is designed to give developers comprehensive control over the entire user experience. While many frameworks limit your reach to the content within a web view, Velox provides native Swift APIs that manage the complete application shell. This includes seamless integration for native menu support and system tray functionality, as well as granular control over context menus. Beyond the interface, you can programmatically handle window-level operations like sizing, titles, and zooming. Velox also exposes critical web view controls, such as navigation and developer tools, directly through its native interface. By leveraging these Swift APIs, you can ensure your application feels like a first-class citizen on the desktop, with deep hooks into the operating system's native lifecycle and UI components. Building for release involves a streamlined process that transforms your source code and assets into a production-ready macOS application. The first phase is bundling. By executing the Velox build-bundle command, the system automatically constructs a complete macOS application bundle structure, integrating your Swift logic alongside web resources like HTML and CSS. Next is configuration. This step leverages your velox.json settings to automatically generate the necessary info.plist and entitlements files, ensuring your application is correctly defined and permitted for the macOS environment. Finally, we move to distribution. The toolchain manages the complex workflows required for modern software delivery, including code signing, Apple notarization, and the creation of DMG files for user installation. Our runtime environment offers a comprehensive suite of proven capabilities designed to handle the most demanding application requirements. As shown here, the platform natively supports multi-window configurations for complex layouts and integrated splash screens to ensure a polished user experience from the moment of launch. For data-intensive applications, we provide high-performance streaming support. We also include deep OS integration through system tray functionality and the ability to manage multiple concurrent web instances via multi-web view. Finally, our run-return feature provides a robust mechanism for execution flow control. The maturity of our runtime is further demonstrated by the diverse range of examples available in our repository, providing developers with a solid foundation for building production-ready applications. Velox combines the joy of Swift with the power of the web to eliminate the friction commonly found in desktop development. By moving away from the complexities of Rust and intricate build chains, developers can leverage pure Swift backends paired with modern web frontends. You can start building your next application today by visiting github.com/veloxapps/thelox.